All right, Unit 11, Lesson 4 is Systems of Linear Inequalities. So, linear inequalities from last quarter, they will have dotted or solid lines, and they will also have shading where the answers are true. So, all the solutions, all right? So, the solution, which is actually plural, to a system of linear inequalities is where the graphs overlap, and that means the shading. It's where both equations are shaded and make both equations true, all the ordered pairs. So, as a reminder, if you see the symbol greater than or less than, that means that you want to use a dotted line. And if you have less than or equal, greater than or equal, that's when you get a solid line. All right, so steps for linear solving. We are going to, 1, graph each inequality, include the shading, and I like to use different colors, okay? And 2, you want to, if it's not obvious, you want to highlight all of your solutions where the shading overlaps. Now, if you can see it in your head, that's fine, and you might only have one final answer, but it's good to kind of have the work. So number 1, if we have y is less than or equal to -2. So you had to remember, you go to the y at -2, and it's going to be a horizontal line. Since we don't have the bar, we're going to make this dotted. Okay? Now, since I want less, that means below. So I'm going to shade below. Okay? And we just want to make it light. So then, this equation, I need to solve that for y. So we'll subtract x. So we get y is greater than -x plus 1. So I'm going to go up 1, and then our slope is -1. And we'll just do a couple of points in each direction. We have the bar, so this is going to be a dotted line. Okay? And then this graph, we want this to be greater, so that's going to be above. So I'm going to look. I have yellow and orange shading, and I want to see where do those overlap. So if I look, it's right down here. So I'm going to make that really dark. That is my answer. If I can't tell where your answer is, you're welcome to highlight it like I did. But otherwise, if you use colors, I can see where they overlapped. Okay? All right, let's try another one. So both of these equations we need to solve for y. We're going to subtract 4x. So -3y is less than -4x plus 9, and divide by -3. Remember, when you divide by -3, you need to reverse your symbol. So we're going to go down 3, and then our slope is 4/3. So 1, 2, 3, 4, 1, 2, 3. And a dotted line. We want greater, so that is above. And so kind of what I like to do is I kind of also just show my arrows if you don't want to shade the whole thing, okay? So then we're going to do our second equation. We will subtract x and divide by 3. So up 2, and then our slope is -1/3. This is a dotted line. And so both lines kind of put your graph into 4 new quadrants. This is greater, so we want to shade above the red line. I really like to use colors. So now our final answer is going to be where both of our arrows overlap. So I can see they're going together up here. So all of these points our solutions. And so if you don't like the shading, you can kind of draw your arrows and see where they point together. All right, let's try our last example. We'll subtract 4x. So I'm going to go down 1, and my slope is -4. 1, 2, 3, 4 over 1, and then 1, 2, 3, 4 over 1. I like to do a couple. This is a dotted line. And we want less, so that's below. So we're going to shade this side. Okay. This is already isolated for y, so we're going to go up 3. And I have the same slope. 1, 2, 3, 4. 1, 2, 3, 4. We get a solid line. And I want greater, so we're going to shade above. So my lines are parallel. That does not mean I don't have any solutions, because I could have to the left where they're between or on opposite sides. So our arrows go opposite directions, which means they never overlap. So this is no solution. If our symbols would have been reversed, it could have been this space between the lines. So don't think just because they're parallel, it means we have no solution. That's not true. They just don't overlap. So if a point is a solution to a system, then the point must make both inequalities true. So everybody checks the first one, they don't always check the second one. So let's look at our example. Is this ordered pair a solution? So we need to substitute. If x is 0 and y is 1, we want to see if this is true. So 1 is greater than 0 minus 3 is -3. And that's true. Is 1 greater than or equal to 0 minus 1? Yeah. So yes. Okay. And let's try this one. This says state one solution to the system. Well, you can guess and check, or you can graph them. I'm going to do a quick graph because there's lots and I can't really tell. I don't want to guess and check. So if we solve this for y, we get y is greater than -x plus 2. And we can just use a rough graph. -1 over 1. All right. And we want greater, so we're going to shade this side. And then I get y is greater than or equal to -4x minus 1. So -1 and then down 4 over 1. So, and we want this also to be greater. So they would overlap in this region. So I just need to pick any ordered pair over here. So I don't know, let's just pick 5, 2. And we'll double check. Is 5 plus 2 greater than 2? Yes. Is 20 plus 2 greater than -1? So I came up with one. I didn't need a super accurate graph, but there's tons of right answers that would work.